This is the Battery Designer 3.1.8 update. It's not quite 3.2 because it does not have mobile support, but it has a lot of new features. Number one, performance is dramatically increased. Lag is a thing of the past. Look, it's so fast that we can do things like this. And we can do things like this. Look, auto layout, 10S 14p. We can just paint the battery out and it will design it for us. You can see what happens if we give it more room down here. It's like a liquid, see? So we can just find the battery. Obviously we don't want a battery that shape, right? The frame is red when there's an uneven amount of cells in the series groups. So it'll be totally white, and that's just because I have those for my colors. You can set your own colors. In this case, it's totally white no matter how many cells I paint because it has enough cells to make all the groups. And there's not an incomplete cell, or incomplete cell group. But see, now there's an incomplete cell group. See? So let's get this battery to a reasonable shape. There we go. We can analyze the performance. It's 98% consistent, has lots of connections. Here's all the different batteries that would fit in it. If you turn auto off, you can go through these. And so on. It also shows the bus bars for both sides, so you know how to make the connections. And you can adjust the parameters of the bus bars by going to Parameters, Bus Bars, and you can adjust those things. You can adjust the bus bar color to make it match either copper, nickel, or you can give it your own. I wanted to show some of the new user interface options. So first of all, let's turn off bus bars. Okay, now the default is the pastels. For the cell colors, I personally think this is the best way to easily visualize the separation between cell groups and everything. If you go to red-black, you'll see, which cells need to be up and which cells need to be down. And you can see how in this battery configuration, it's easy because they're all in simple groups. But in more complex battery situations, it's difficult. I'll show you. This is the battery viewer. You can get to it through its own URL, or you can click Social and then Battery Viewer, and it'll open it up here. But going back over here, this is all the batteries that people save. I've obviously saved the most batteries, and a lot of them are just test runs. Okay, so let's open this one up. And let's switch the frame type. There we go. Okay. So you see how with the pastels, we can clearly see, let's turn this down. We can clearly see all the different cell groups, right? But if you change this to red-black, it becomes difficult, right, to kind of follow it because they merge together right here and right here. You see? So these pastels really help with that. I just recently used it, so this is a great time to explain what this is. It will look better soon. I understand the sizing isn't right when there's a large thing inside the box. The box should get wider and these things should move over. They don't currently, but it all works. Okay, so basically any menu item up here, even if it's a link to another menu item, for example, the parameters, you can drag over here. You have to drag from the icon. You can't drag from here, it's not going to work. You can't drag from the text, it's not going to work. You have to drag from the icon, see? And you can remove it by right-clicking. It confirms it. You can even remove the slot to clean up the page as much as possible. So this is a quick slot area for you to put things, the most commonly used things, see? And I don't go in there too often because I bring those things out here, so I won't put that there. You can make it go away if you press Q. You can make the top one, the main one, go away if you press M. See, so if you have M and Q pressed, you're full screen here. Okay, I'm going to briefly go through just all the options in the top. Okay, we have generate. These are the things that output stuff. Some of them are generation items themselves. For example, if I click bus bars, it will generate the bus bars. There we have it. We can open this window. The next is frame generation. Click fast frame and it will generate an STL file of the battery frame ready to print. Frame does the same thing, but it's using an old version of the frame generator that's much slower. So I don't recommend using that, but here we have it. You can adjust the frame parameters. Let's go, we've got fast frame down here on the quick link, so that's good. Let's go over to parameters, frame parameters, and then we can adjust the frame thickness. Look, let's make it 8 millimeters, and then do another fast frame. And there we have it. There are several frame types. Right now we're on contour. There's also rounded, and we can get a preview of that. See, we don't have to regenerate. And we can see what that's going to look like, but I'll generate each one, obviously, for this video. So let's do a fast frame. There we go. Now you can see it's filled in those areas. That's better for some situations. Square frame is not good for this situation, because that's going to do exactly what you think. That's obviously a lot of wasted space. And that's what this one does. It puts a square around each cell and then merges them. This is similar, but it's smoothed. And then we have your typical cell holders. There we are. And then circle frame, which absolutely is not going to make sense for this battery, but let's do it anyway. And there we go. Okay, so let's go back to a reasonable frame. Let's go back to the contour frame. And I want to show you the other parameters for the frame. You see the distance between the outside of the perimeter cell and the frame edge? That is adjustable. That's the frame margin. That's a 3 millimeter gap. We can make it larger, and look, it shows it in real time. So we don't have to go through all of these generation options, but I'll show you a couple. Let's do this one. The 3D view has its own viewport, so you can make it real small and out of the way, but still be able to see the 3D frame. And there we go. We've got the thicker frame margin. You can even do a negative frame margin for an ultra compact battery, something like this. Okay, these parameters here are for the stopper rings. That's what I call these guys right here. So we can adjust the stopper ring height. Right now it's at 0.4. Let's go up to 3.4 and see what happens. It's going to be the height of this along this axis. There we go. That's very large. You wouldn't want to actually do that, but that's what that is. This one here is the thickness. That's going out this way. So it's this top surface that you see. See? So let's put it at reasonable figures. Let's just do like 1.2 and 1. And then do a generation. There we go. That's buildable. Okay, now you see the number of divisions here? That'll work just fine, honestly. But you can increase the quality. So let's do 40. As you can see, that did not make much of a difference. So let's go up to 75. If you notice, it takes a little longer as you increase the quality. If you have the quality up high, like a 70, 80, or 128, and you click frame instead of fast frame, it's going to take a very long time, just letting you know. But fast frame is fast, relatively speaking. So let's fix this frame margin issue because we've pulled the frame margin in too much. You very rarely want to do a negative frame margin anyway. I was just showing you that you can. So let's repair this issue. There we go. And I can show you the smoothing. This is a perfect spot to show you the smoothing. It takes longer because it adds more geometry. And you get the idea. If you go to Settings, UI, you can change the frame color to anything you'd like. And you can also set the error color for the frame. So that would be this right here. So we can say blue when error and yellow when good. Then come over here and paint. We are in error. Why? Because group 6 only has 10 cells. The rest have 14. That's because the selection I had, this layout I had when I had auto layout on, tried to put that layout in there and it didn't fit and I didn't do anything about it. So we can change this. We can hold Control and remove the cells. We can increase the brush size. Oops, that's easy to fix. Just right click, drag. Okay, so now we can put our cells in. We can manually build a battery. A and D on the keyboard cycle through the numbers. And we can see what fits. Look, so we know 16S 5P fits in here. So let's do it. So let's set our frame color to something more logical. We'll make it green when it's good and reddish when it's bad. Okay. So if the number of cells we have in each group is not even, then it will say that it's bad. Right now there's no cells there, so it's saying it's bad. 1, 2, see now it's instantly good because this is the first group. We're going to do 5P. Let's do the second one. 1, 2, see now it's bad. Oh, it's good again. It's bad. And it's good again. You see, that's how that works. So you always know when you've completed the group. Now this is a very poor cell layout that I'm doing. On purpose. You can also paint. You don't have to click. I usually use a combination of both. And look, perfect ending with no extra cells. But we have a problem. Look over here. Look, we have a 36% connection consistency, and we have some that have very low connections. Now, as you can see, if it has one connection, it's red. If it has 2 connections, it's yellow, and I really need to make that text black so it's easier to see. If it has 3 connections, it's orange, and if it has 4 or more, it's blue. Under parameters and cell grid, you can shift up or shift down the cell groups. So follow the 1 there. And this is the original position it was in, so we could reverse it here. And then now we have main battery negative over here and main battery positive over here. If you go to parameters and battery, you can put your actual cell in. So let's say it's a Molicel P42A. So you can say it is 4.2 amp hours. You can do 45 max, and I think they just rate it the same, right? 45 continuous on those cells. At least most places I've seen it. And the resistance, those are like 15 or something like that, milliohms. That's already correct. And we can do the simulation for 150 amp load. So once we put those values in, it affects this simulate button, and it also shows you the stats down here. Now, you can see you've got the resistance in real time. So if I change this, it updates that in real time. Because we have the resistance and nominal voltage of the battery, we can simulate it to see how it would perform at steps all the way up to the set load current. So we can see what its voltage drop is going to be at a particular current. We can see what its efficiency will be at a particular current. I made all the lines turn red after it drops below 90% efficiency, just as a general rule of thumb of where you want it to be. So you can see with Molicel P42As in this configuration, we get 735 watts of power loss at 90% efficiency. That sounds like a lot, but as long as you keep it above 90% efficient, you're in an ideal situation. Because you have to compare the power loss to the total power. The green line is the expected line. It's the simple volts times amps equation. The curved line is much closer to reality. It's not exactly reality because it doesn't consider the resistance of the series connections. But it does consider the resistance and its effect on the battery over a range of currents. And it does calculate the resistance based on the cell configuration. So it's much closer to reality than the green line, and it's not very far from reality. So let's compare that to like LG MH1s. We don't really have to change the capacity because we're just going to do the charts. So all we need to do is change the resistance. LG MH1, let's just do 32 milliohms. That's reasonable for those cells. And we can see the difference. You see how much sooner the line gets red. It's the same battery and the same configuration, just different cells. Same voltage and everything. Well, obviously it will be a smaller capacity, but that doesn't matter for these performance figures. But look, we drop below 90% efficiency at just 60 amps here. In contrast, we get 123.75 amps with the Molicels. Now let's check out power loss. At 150 amps, we're getting 2.3 kilowatts of power loss. I mean, but here, all the way up to 150 amps, we're only getting 1 kilowatt of power loss. Now, you obviously don't want to do that, but that's not going to kill these cells for a few seconds. We're getting 15.36 volts of drop at 150 amps with the LG MH1s. But if we go to the Molicels, we're getting just 7.2 volts of drop at 150 amps. Not only can you compare different types of cells, but you can compare different numbers of cells in parallel. For example, okay, let's go back to Molicel figures, and let's take one cell out of parallel for each one. So control click just to remove. This obviously is destroying the battery, but it'll be okay. Okay, we've got a valid battery, according to how it's currently set up. And then let's simulate it. This is a 5P Molicel on the left and 4P Molicel on the right. And you can see the red portion is larger for the one that has less cells in parallel, and that just makes sense. So with 5P, we get 6,393 watts. At 4P, we get 5,822 watts. It's much easier to design any battery that's not a triangle battery. Oops, there we go. For example, let's just get a nice block. Now you can either paint with whatever cell number, or you can hold control and make them gray. Best thing to do is to make them gray, so it defines a battery shape that's not linked to any cell group number. So we don't have a lot of options in here, so look, we can just lower the brush size and just add one at a time until we find one. There we go. Look, now look at all the options we have here. With 108 cells, if you use all of the cells, you can build these batteries. You could obviously build way more types of batteries within this shape if you don't use all of the cells, but this shows you all of the configurations that use all of these cells. So we have this one. Let's turn the bus bars off, and let's do red black. Still a valid battery. That's still a good battery. 97% consistent. Lots of connections. You see how easy it is to design a block battery, or it doesn't even have to be a perfect block. You know, just not a triangle. Not something with really tight corners. But this can even be difficult if the amount in parallel goes down, and we'll get there. Ah, here it goes. This is where it starts to mess up. We can turn back to pastels. See? It's broken up the cell groups, but it's not hard to repair it. Check it out. It's already generated a relatively good layout. We can go over here and just swap these. We can make this one a 2, and we'll make this one a 1. Okay, we've resolved that problem. You can also quickly make batteries that have repeating patterns, and I'll show you how to do that. If you define any 2 pairs, but they have to be a certain type of arrangement. You see how these are totally the same, and you could infinitely place them this way and they would never overlap or have any problems? Well, if you do 2 like that, you can press C to continue the layout. And you do 10, and it will make 10 total. If you do 5, it will make 5 total. So it doesn't add that number, it stretches it out, or it continues it to that number. So we can do a very simple one. 1, 2, 3, 1, 2, 3, continue, 10. That's the quickest way possible to design a 10S 3P battery, let me tell you. We can generate the frame for that. And you can see I have the quality up high still. That's why it took a little longer to generate, so we can fix that. We can go to parameters, frame quality, turn this back down to a reasonable number, and then generate again, just to see the difference in time. See, it's definitely faster. So let's explore more of the generation options. We can obviously do the bus bars. I already showed you that, but let's go ahead and do them again. And we can do the frame, obviously. We can do a case. This is very beta. It is not pretty. It takes a long time to generate, considering the size of the battery, and it's not functional right now. It's just a concept. But it will eventually generate an entire e-bike mountable 3D printable battery case that will fit any battery that you design in this program. And this is it right here. Container basic and tray and the table elements are pretty much also experimental alpha level features, so there's no sense wasting time on those in this video. Cells, however, is useful for presenting your model. It generates the cells that would be in the battery pack. So you can export these to Tinkercad or whatever else, to put with the frames and the generated bus bars to create a nice 3D model of your battery. If we go back to generate, there is the cell punch. This is actually a functional model, and you can use this to cut the cell holes and stopper rings out of any shape. So basically you would make this a negative and you would place it on a shape and cut it out of that shape after aligning it with the bottom. So I'll show you how to do that because I need to explain how to get the STL file. You go to export and download STL. You have to generate it first and it'll show up in the window, of course, and then you can download it. So we'll call this cell punch. As you can see, I've done this a few times. And let's go over to Tinkercad. Okay, I'm in Tinkercad with the cell punch and this block. This can be any shape. And for this example, I'm just going to make it so it fits. We want to make it the same height as the cell punch, which will be the same height as the frame thickness. And then we can center this or place it anywhere. Make it a hole and merge. This will give you your cell holes and your stopper rings per the settings in the program. If you want to get the SVG file, then you would toggle this. Now I know it's a little confusing. I'm eventually going to make it so you can click a button and it will generate and download just the SVG file, but right now it kind of generates everything and you have to select this to choose if you want to also get the SVG file. So when I do fast frame with SVG toggled on, it will download the SVG file automatically. You can also get a DXF file and it will have everything in it. There we go. We'll call it battery. And there it is. It's the frame polygon with every cell hole and every stopper ring. When you download the BD3 file, it not only captures the battery itself, but also all the menus and stuff. So if you set it to a certain frame type or a certain color or whatever, it'll capture all of that so that when you load it, it'll restore all of the settings, not just the cell layout. Under visibility, we can turn on and off everything. So there's the frame, the cell grid itself, the cells themselves, the cell numbers, and the bounding box as you saw earlier. This doesn't do anything. It will turn stats on and off, and I'll probably rename it to stats or something like that, but you can just minimize it. It's fine. And this, of course, will expose or hide each side's bus bars. In tools, we just have various tools. The one you're going to use most of the time is going to be the paint tool. That's the default. Here's the move tool. You can't see it while you're dragging, but you can drag the battery. You could see it before, but there's a bug. I've got to fix that. I've changed a lot of things, and I broke it. I'll fix it. Paint is obviously the paint tool. There is a fill tool. It is very new. It is very experimental. But let's say we have this over here. We have all the same cell number, and it encloses empty cells. It works. Eraser is obvious, but you never really have to switch to eraser because when you're on paint, you can just right-click to erase. You can compare size on linear and offset layouts. If you go to visibility and turn the bounding box on, it's on. And then we can do this. And then do continue, and then 10. There we go. And then we can click grid type and see the difference. 208 by 108, and then 196 by 121. So it just depends on your situation. Offset's not always best. It usually is. And you need at least 3 cell rows for it to make sense. So now let's explore the auto layout more. Let's set the brush size to 4. And let's make it, remember, it works best when you have more cells in parallel than the battery is wide. Or at least even or more. So let's make it 6p. because we have the brush size set to 4. So that should give us no problem when painting a battery. Currently it's set to 10S, but we can do 4S. Let's make a 4S 6P battery. Oh, and you got to turn auto on. There we go. And there we have it. It's very easy to make. You just delete the rest. You can, oops, you can mold it and shape it. There we go. And get it right down to the size that you want. You can see we've got 100% consistency, 7, 7, and 7. And we can fit all of these batteries in there. Let's do another one. Let's do 16S 8P with a size 6 brush. And here we have it, a very weird, but definitely functional. Wait, nope, it's not functional. We got to repair that. We could go in there and repair it, or we could just squeeze it in, see? But now it's red because we don't have it long enough. So we just add some more length. Trim off the edges. Push this down here. Poke this out here. It's that simple. Do we have a good one now? We're good here, we're good here, we're good here. We're broken up again. You see, so look. If it's too wide, you see how it's wider here? It gets really confused, see? So let's do more in parallel. Look, with 14 in parallel, we don't have this problem at all at these dimensions. We can even make it wider. I keep doing that. We don't have enough. We have enough. We have exactly enough. Nope. 16. We got to go to 16. So we can make this way wider. And we can make the brush smaller. Okay. There we go. We have a valid battery. With these are terrible cells. Terrible cells if they've got 47.3 milliohms of resistance. But we've got so many in parallel that it's brought the battery down to 54.06 milliohms. So let's simulate that over 200 amps. Let's go to parameters, battery, load current, and you can see it maxes out at 100, but you can type in any figure you want. 200 amps and simulate. We can see efficiency drops to 90% at 110 amps. So those cells are bad, but we can still do 110 amps on this battery because we have so many in parallel. Let's compare that to a 4P. Change this to 4, and we'll have to make this very thin. You see? So let's remove these. You see how it will fill out that space. Okay. There we go. We've got a valid battery. Decent amount of connections as far as consistency, and you know, they're not like 1s or 2s, but we do have some 4s in there. Not a super great battery. And it's using terrible cells. Remember, we could do 110 amps when we had much more in parallel. What can we do now? Look at this. At 35 amps, we go below 90%. Look what happens. After 150 amps, the more current you give it, the less power you get. That's the difference with the number of cells in parallel. I really hope I covered everything. There's so many new features of this program, and I still have so much work to do on the user interface, and there's many more features that I want to add. Oh, there's one thing. Look, you can go to parameters, cell grid. This is a brand new feature from just today. or yesterday. And you have this X and Y modifier. So you can adjust the cell spacing independently along the X and Y axis, see? So if you want to make a really skinny, narrow battery, or if it's got to fit in a certain proprietary situation, you can do that. Okay, that's it. Thanks for watching.